Hi, in the second of our firebreak lessons, I want us to look at the water that's on Earth again. But this time, I want to break it down to look at where this water is. What are the different stores that we find the water that exists on the planet? You have this diagram in your booklet on page 6. We're working on pages 6 and 7 today of the Theme 11 booklet. This shows the volume of water held up in each of these different potential stores. What I'd like you to do, firstly, is to work out the total amount of water that there is on Earth. So I'd like you to add up all of these volumes from the different stores that are available. Can we also pick out how much of this is actually available for use for humans? Deep groundwater, for example, is usually salty and it's too deep really to be able to get access to it. People don't drill down 800 meters to pump water to the surface to use. It'd be unusable and it'd be way too expensive. Okay, so which of these sources do you think are available for us to use, and how much water is that? Okay, once we've got that total, I want us to try and represent that data by means of drawing some squares to scale. The scale I'd like you to use is 1 square centimetre is the equivalent of 10 million cubic kilometres. We are dealing with some fairly big numbers here, so but yeah, 1 square centimetre is 10 million cubic kilometres. So once you've got a total, you can then divide that by 10 million, and that'll give us the number of square centimetres that we need to colour in for each of the things I've asked you to do. Okay. You do need to think though about how you'd work out how big the square would need to be once you've worked out the area of that square. How can you work out the size of the sides of that square? So, press pause now and have a go at those activities on pages 6 and 7. See what you can come up with. Okay, let's have a look at some answers. The first thing we needed to do was to add up all these different stores of water to work out how much volume of water we have on Earth. So if we add all these up, either by putting them in your calculator or by perhaps even just turning them into the same powers all the way through, we have a total of 1,387,599,600 cubic kilometres. Bit of an unwieldy number. Let's simplify that a bit, put it as two significant figures, and we have 1.4 billion cubic kilometres, or 1.4 times 10 to the 9 cubic kilometres. Okay, that seems like a big number. But if we think about for a moment how much of that we can actually use to supply the needs of all us, really we've only got 3 sources of fresh water at or close to the surface that we can easily access. Either lakes, soil or shallow groundwater. We could also perhaps add in the atmosphere, because we do eventually get that falling as rain. But that's really what we have. So out of that 1,400 million cubic kilometres of water, we get 4.2 million cubic kilometres that we can use. Perhaps it's not a lot. We'll come back to that idea a little bit later on. Okay, I asked you then to show some of this data in the form of squares drawn to scale. And the scale I asked you to use was 1 square centimetre equals 10 million cubic kilometres. So if I want to work out the Earth's water on this scale, we have 1.4 billion cubic kilometres. Divide that by 10 million. That gives us 140. So 140 square centimetres would represent, at this scale, all the Earth's water. If I want to work out how big the square is, I square root that. So I know that to get a square of 140 square centimetres, I need to draw a square with sides of 11.8 centimetres long. Something that looks like that. I then ask you to work out how much of this is the glaciers. Now, glaciers are 2.9 times 10 to the 7, or cubic kilometres. Fairly easy to work out then. Our square on the same scale must be 2.9 square centimetres. Square root that, and we have a square of 1.7 centimetres long. So you can see glaciers are really quite a small proportion of the Earth's water. If we actually start working out some percentages here, the percentage of the Earth's water that's in glaciers, if we take the volume of glacial water, divide it by the total volume of water, multiply by 100, it's 2.1%. All the fresh water added together is 3.8 times 10 to the 7. Divide that by the total amount of Earth's water, multiply by 100. All the fresh water together, which includes the glaciers, is 2.7%. So only 0.6% of the Earth's water is actually fresh and available to us. We can see from this that the Earth's oceans are a really important store of Earth's water. Crucially for us though, as humans, only a tiny proportion of that is actually available for us to use. It makes it really important for us to manage our water resources well. With an ever-expanding population and a finite amount of water, and only a small part of that water actually being usable, we must be really careful with it. Anyway, next time we're going to start looking at what happened to sea level during the last glacial period. How do you think sea level would change during a major global glaciation? Anyway, more of that next time. I'll see you then. But before I go, this would be a really good time to go back and revisit what's in a word. Are there any words now that we can come up with better definitions for? Work through the table, fill in anything that you want to improve or anything you now know that you didn't know at the start of the theme. I'll see you next time.